Viking Science Myth-Busting presents Candles Under Jars. Oh, we must move the Viking hat of science. All right, there is a pervasive misconception regarding the explanation for why the following happens. Let's move this a little closer. That if I have a candle burning in a bin of colored water here, and if I put this jar, open jar, into the water, that water ends up in the jar. And the common misconception is that the water goes into the jar because the burning candle used up the oxygen, creating a partial vacuum, and the water was pushed into the jar. Well, that explanation is just not consistent with the number of observations we can make. So let's watch a little bit here and see if we can see what's going on. Oh, first, the reason for this, that the water ends up in the jar, has mostly to do with the heating of the air by the flame from the candle, which causes the air inside the jar to expand and leave the jar. So then after the candle goes out, the air cools again, and water rises to replace that lost air. So watch what happens to the water level in the jar after the candle goes out. It's slowly rising, candle goes out, and the water jumps up a little bit into the jar. In fact, the water rose more quickly as the flame got smaller and the candle went out. So if the water is rising after the candle is done burning and done using oxygen, it must be something else that's going on besides the candle using oxygen that causes the water to end up in the jar. Now if we put the jar down quickly this time, you'll notice some bubbles escaped. Again, as you watch, the candle goes out and the water level jumps up in the jar. Now those bubbles you saw and heard were the air that was leaving the jar because it was being heated by the candle, so it expanded out through the water in this case, and was lost. And you don't see the bubbles if you put the jar down slowly, because the air has already escaped before the opening is beneath the water. Gotta get a paper towel here quick, dry this out. Another way we can look at this is if I hold the jar above the candle. So now I'm heating the air in the jar, but I am not using oxygen from the jar to support the combustion of the flame, and then I quickly put it in the water, we end up with a significant volume of water in the jar. Again, that was the air being heated and escaping the jar, and then when it cooled, the air that was left was replaced by the water. In fact, a couple minutes ago, I measured the volume of water in the cylinder, and it was about 65 milliliters, or 25% of the volume of one of these jars, which is it's a higher percentage volume than oxygen in the air. And if I use this larger jar here, again, I've got to wipe it out here, sorry, I should have that done. We can see this all a little bit better because of the bigger volume of air. So, bubbles escaping, that's the air leaving the jar, and after the candle goes out, the water level jumps significantly into the jar. Again, that's because some of the air has been lost. Then when it cools down, the air contracts and the water goes in to replace the air that was lost. Again, so it all mostly has to do with heating and expansion of the air by the heat of the flame. In actuality, only a small percentage of the water that ends up in the jar is due to the oxygen that was used, because the candle will go out when it's used only about a third of the oxygen or so, approximately, in the jar. And not only does the candle use oxygen from the air, it puts carbon dioxide gas back into the air to replace that space that used to be occupied by oxygen, at least half of it. Well, thank you for watching this installment of Viking Science. Apologies for the quality of the video, but we don't have the budget for a film crew. Thank you.